All right, let's do this. Let's implement Thompson sampling. So we already initialized, the main parameters, which are part of the common framework between Thompson sampling and UCB. So this is n, the total number of rounds or the total number of users to whom we're going to show successively the ads. And then we have the number of ads, which is 10 here. We're dealing with 10 different designs of ads, which we are experimenting to figure out which one has the highest conversion rate. And then we have this list, which is initialized as an empty list, but which will be populated over the rounds with the different ads that we select. So at the end, it will contain all the different ads that were selected at each round. And now what we're about to code is specific to Thompson sampling. So there we go. We're going to start with the first step, step 1, which says that at each round n, we actually consider two numbers for each ad I. And I1n, which is the number of times the ad I got reward 1 up to round n, and I0n, the number of times the ad I got reward 0 up to round n. So basically what we have to do in this step 1 is create two variables here for these two numbers, and we have to initialize them, of course, as 0. 0 for both, because of course, before we begin, the first round, well, these two numbers are equal to 0 because the ad didn't get any reward at all. So that's what I would like you to do. And since, these numbers are for each ad I, well, what we're going to do is we will create a list of 10 elements where each element is indeed this number for each of the ads, right? And same for this one. So now your turn. Please press pause on the video and create two variables which will initialize these two lists of numbers. And you can call these two lists. First, for this one, you can call it numbers of rewards 1, with underscores. And for this one, you can call it numbers of rewards 0. Okay, so please press pause and I'll give you the solution in a second. Okay, good. Let's do this together. So as we said, we want to introduce two new variables, which will be two lists. First, for the numbers of times each ad gets the reward 1, and we're going to call that numbers of rewards 1, all right? And as we said, we want to initialize it as a list of 10 elements, and all these elements should be initialized to zeros, because at the beginning, no ad got any reward, right? And remember the trick to initialize a list of 10 zeros, it is to put a 0 here in square brackets and then multiply this by d. Okay? And then, very simply, for the other list, corresponding to these numbers, well, same, we're going to call that numbers of rewards, not 1, but 0, and same, we initialize it as a list of 10 zeros. And over the rounds, the elements of these lists will be populated for this one as soon as an ad receives a reward 1, in which case we increment the element corresponding to the ad by 1, and same for this one, each time an ad gets a reward 0, we increment the element corresponding to this ad in the list. Okay? So very simply, and that's the two parameters specific to Thompson sampling. So if you got this too, well, congratulations, you just implemented step 1. All right, so now, according to you, what do we have to do? Well, not yet the big for loop. Remember that we also want to keep the accumulated reward that we, accumulate over time. And we're going to introduce the same variable as in UCB. We could have even kept it in the framework, but remember that variable is total reward. So here we introduce the same new variable, which of course we initialize still to 0. And now we can start the for loop. That main for loop, which will iterate through all the 10,000 rounds. In each, we will show an ad to a user, which will decide to click yes or no on the ad. And so there we go. Let's start this loop. So it's exactly the same as in the UCB. We start with 4, then we choose n for the iterative variable because same, n represents the rounds. And then n will go in the range from same 0, because indexes in Python start from 0, up to n, right? The total number of rounds or the total number of customers or users to whom we show successively the ad. And then colon, and there we go. Here we are inside this big first for loop. All right, so according to you, what will be the first step here? There is a second for loop coming up. It is the for loop that will iterate through the different ads. But before this, we need to introduce a new variable, which we already did in the UCB implementation. Remember, we need to introduce that variable, which will be the add that we select at each round n. And as in the UCB implementation, we will introduce that variable as add, right? Add, which will be the index of the add that will be selected at each round n. And we initialize this to 0 because, you know, we're going to have that second for loop that will iterate through different adds starting from 0 up to the last one of index 9. Okay? Then let's have a look at the algorithm. And let's see if we need to introduce a new variable, you know, before we start this second for loop. I remind that, you know, for UCB, we indeed had to introduce a new variable here, which was max upper bound. You know, we introduced max upper bound and initialized it to 0 before we started the second for loop. Okay? So here, that's kind of the same. Let's see if we have to introduce a new variable other than the add one before starting this second for loop. And, well, you know, when we have a look at step 3 here, we see that indeed we select the add that has the highest of these random draws, you know, taken from the beta distributions, and therefore there is still a maximum value to consider here. And that's exactly what we will introduce as a new variable just before starting this second for loop. That new variable will be exactly that maximum of the random draws, and we're going to call it max underscore random. Okay, max random, which we will initialize, of course, to 0. And now we can start the second for loop. All right, so let's do this. Try to do it faster than me. You know exactly how to do it. We start with 4. Then, you know, the iterated variable will still be I, which will iterate through the different adds from 0 to 9 because they are the indexes. So for I in the range from indeed 0 to, well, D, because we had the D variable for the number of adds. And then colon, and there we go. Now is the time we implement the next step in the Thompson sampling algorithm. I'm talking, of course, about step 2, where for each add I, well, that's exactly what this second for loop is about, you know, it will implement step 2 for each of the add I from 0 to 9. And so for each of these adds, we take a random draw from the beta distribution given below of parameters NIN plus 1, where NIN is, of course, the number of times the add I got reward 1 up to round n, and the second parameter, NI0N plus 1, where NI0N is, of course, the number of times the add I got reward 0 up to round n. So that means you can totally implement this step 2 on your own because you have all the parameters, right? We already introduced these 2 new variables. We initialized them the right way. And so now you can totally implement the step 2 on your own before we do it together. I will just give you a hint, unless you don't want to listen to it and look into the documentation online, which is even better. But I'll give you that hint anyway. The way to get the random draw from a beta distribution of these parameters is given by a certain function of, well, this random library, which we, by the way, already imported in our implementation. That random library, well, this random library contains a certain function which can give you exactly what you want here, meaning a random draw from the beta distribution of any parameters. And that function is called Bias-Variate, in one word, Betavariate. Okay, so that's the function. That's all I'm going to tell you. And so now you can really implement this step 2 on your own. So please press pause on this video and we'll implement the solution together in a few seconds. All right, are you ready? I hope you got it correct. Really, there is no trap, so it should be totally fine, but let's do this. So here we are at the beginning of the second for loop iterating through the different adds. And so what we have to do is collect for each of these adds this particular number taken as a random draw of this beta distribution called with these parameters. So let's do this. First, we're going to introduce a new variable, which will be exactly that random draw. And we're going to call it random underscore beta. So that's exactly the random draw taken from the beta distribution of these 2 parameters. So random beta, and then as I told you, the way to get the random draw from a beta distribution of certain parameters, well, we first need to call the random library from which we're going to call the Bias-Variate function. All right, so that's the function. And inside this function, well, of course, we input these two parameters, nin plus 1 and nin 0 plus 1. And since right now we're dealing with a specific add, the add I in this second for loop, so it starts from 0 and then goes to 1, 2, 3, etc. up to 9, well, these two parameters that we have to enter are for this specific add I, meaning for the specific index I in these two numbers, an I1n and an I0n, okay? And therefore, the way to get these two numbers is by calling our list of numbers of rewards 1, the number of times each add, and especially our add I we're dealing with right now, got the reward 1. So we take this list, we paste it inside this beta variate function as the first parameter, and then of course we take the index I, right? Because we're dealing right now with this specific add I in this second for loop. And then let's not forget the plus 1, and then same for the second parameter. That's going to be the number of times this particular add I we're dealing with right now in the second for loop has received the reward 0. So here I'm pasting that, but I don't forget to take the index I of this add I. And then of course I add plus 1. Okay, and that's it. That's all you had to do for this step 2. So you see it's actually a bit simpler than the UCB algorithm, but now I trust that you're gonna use the same right trick to implement step 3, because indeed in this step 3, we have to select the add that has the highest of these random draws. We took 10 successive random draws for each of these adds, but inside the same for loop that is iterating through the add, we need to use a trick to keep in memory the highest of these random draws. And at the end of the for loop, we'll get the final highest of these random draws. So the trick that you have to use is exactly the same as in UCB. You're gonna use, of course, this variable max random, which we introduced and initialized to 0 right before this second for loop. And you're gonna use it to keep in memory over this second for loop, well, the maximum of these random draws. So that's the new exercise for you. Your new exercise is basically to implement step 3 with that same trick we already learned in the UCB implementation. And I'll see you in the next tutorial to implement the solution with you. And until then, enjoy machine learning.